which is SOHCAHTOA. The next one is step 4. And this is understanding what sines, cosines and tangents are all about. And these will help you solve trigonometry problems. Sines, cosines and tangents are functions that help you determine both the lengths of the sides of a triangle and the angles. It lets you do both. It lets you work out how long certain sides are, and you can also work at angles using this principle. Now this here is just a basic. It's showing you the sine wave. And you see it ranges from 1 to -1 and it covers 360. This is a sine wave. I'm going to show you how it works later. This is the cosine wave here, the function which ranges from 1 to -1 and it covers 360 degrees. It's slightly different to the sine wave. And this here is a tangent wave, a function which is repeated every 180 degrees. And these functions, these are the waves, but I'm going to explain them a bit later, but they allow you to determine trigonometry problems, but that's how they look. These three functions can all help you determine angles and lengths of right-angled triangles. The key is to determine which of the three functions is appropriate. So that's the key, which of the three functions is appropriate. Sometimes you use the sine wave, sometimes you use the cosine, and sometimes you use the tangent. You've got to decide which function I need to use to solve that particular problem. That's what you've got to do. So how do you decide which one is appropriate? Well, that's where you use the SOHCAHTOA. So what is the rule? So is sine is opposite divided by the hypotenuse. The cosine is the adjacent divided by the hypotenuse. And the tangent is the opposite over adjacent. So you use the sine function when you know the opposite and the hypotenuse. You use the cosine when you know the adjacent and the hypotenuse. And you use the tangent function when you know the opposite and the adjacent. That's the rule. Don't forget SOHCAHTOA, and we will apply it. We will apply it later on. Now again, to determine which wave to apply, which function, you need to identify what is the opposite, what is the adjacent, and what is the hypotenuse. Well, as you can see here, the hypotenuse is always the side opposite the right angle. And it's the longest side. That is the hypotenuse. It's always the one opposite the right angle. So what is the opposite? What's classified as the opposite? Well, look at this case situation here. The opposite one to that angle is the one that is directly opposite the angle you're talking about. So it's not communicating, not touching it at all. So whatever angle you're talking about, the opposite one is the line opposite the angle. It's not touching it. So whichever angle you're using, it's always the opposite. The adjacent side is the side which touches the angle. As you can see here, that's touching it. It's not opposite, it's touching it. That is always the adjacent. Now if we change the angle that we're considering, as you can see here, the opposite and adjacent change, but the hypotenuse stays the same. So in this case now, as you can see, the opposite is that line there. AC is the opposite now, and BC is the adjacent. It depends which angle you're looking at. But get to the angle and look and see, is it adjacent to it or is it opposite it? That's the key to using this function. Let's do an example. Which function would you apply to this triangle if you wanted to know this length here? If I wanted to know that length here, which function would I use? Well, as you can see, you know the adjacent length, don't you? That's the adjacent. And you want to identify the length opposite. Which function includes the adjacent and the opposite? Those two bits. Adjacent and opposite. Look at your SOHCAHTOA. What you can see. What do you get? It's SOHCAHTOA. In this case, it's the tangent. So that's telling you have to use the tangent function. Okay? We'll actually do some calculations later, but I want you to get, first of all, to grasp which function do you use. Let's do another example. Which function would you apply to this triangle if you wanted to know that length there? That's the length we want to know. Well, as you can see, you know the adjacent length, that's 5 centimetres, and you want to identify the hypotenuse. Which function includes both adjacent and hypotenuse? Well, let's go to SOHCAHTOA. Which one of those has the adjacent and the hypotenuse? Well, as you can see, it's the cosine. So in this case, you'd use the cosine function. In this case, you'd use the cosine. Let's do another example. Which function would you apply to this triangle if you wanted to know that length there? Which one did you use? Well, as you can see, you know the opposite length, don't you? You know the opposite. and you want to identify the hypotenuse. Well, which of the functions has this in? Which of the functions has the opposite and the hypotenuse? Well, if you go to SOHCAHTOA, as you can see here, SOHCAHTOA, the ones where the opposite and the hypotenuse is the sine function. So in this case, you'll understand. So do you understand what you've got to try and identify? Which function is appropriate to what I'm trying to determine? Let's do a practical example.